Power requirements during flight. The need for and effects of changes in power are influenced by certain factors, such as the interrelationships of airspeed, pitch attitude, and altitude. Most flight occurs in the region of normal command. In the region of normal command, increasing power increases the airspeed, and decreasing power decreases the airspeed. As the speed of flight decreases, the power required to maintain altitude increases. An inverse relationship between required power and airspeed. The aerodynamic properties of an aircraft generally determine the power requirements at various conditions of flight, while the power plant capabilities generally determine the power available at various conditions of flight. When an aircraft is in steady level flight, a condition of equilibrium must prevail. An unaccelerated condition of flight is achieved when lift equals weight, and the power plant is set for thrust equal to drag. The power required to achieve equilibrium in constant altitude flight at various airspeeds is depicted on a power required curve. The power required curve illustrates the fact that at low airspeeds near the stall or minimum controllable airspeed, the power setting required for steady level flight is quite high. Flight in the region of normal command means that while holding a constant altitude, a higher airspeed requires a higher power setting, and a lower airspeed requires a lower power setting. The majority of aircraft flying, climb, cruise, and maneuvers is conducted in the region of normal command. Flight in the region of reversed command means flight in which a higher airspeed requires a lower power setting, and a lower airspeed requires a higher power setting to hold altitude. It does not imply, however, that a decrease in power will produce lower airspeed. The region of reversed command is encountered in the low speed phases of flight. Flight speeds below the speed for maximum endurance, or the lowest point on the power curve, require higher power settings with a decrease in airspeed. Since the need to increase the required power setting with decreased speed is contrary to the normal command of flight, the regime of flight speeds between the speed for minimum required power setting and the stall speed or the minimum control speed is termed the region of reserved or reversed command. In the region of reversed command, a decrease in airspeed must be accompanied by an increased power setting in order to maintain steady flight. An airplane performing a low airspeed, high pitch attitude power approach for a short field landing is an example of operating in the region of reversed command. If an unacceptably high sink rate should develop, it may be possible for the pilot to reduce or stop the descent by applying power. But without further use of power, the airplane would probably stall or be incapable of flaring for the landing. Merely lowering the nose of the airplane to regain flying speed in this situation without the use of power would result in a rapid sink rate and corresponding loss of altitude. If during a soft field takeoff and climb, for example, the pilot attempts to climb out of ground effect without first attaining normal climb pitch attitude and airspeed, the airplane may inadvertently enter the region of reversed command at a dangerously low altitude. Even with full power, the airplane may be incapable of climbing or even maintaining altitude. And so the pilot's only recourse in this situation is to lower the pitch attitude in order to increase airspeed, which will inevitably result in a loss of altitude. In conclusion, airplane pilots must give particular attention to precise control of airspeed when operating in the low flight speeds of the region of reversed command.